Hello everybody, welcome to episode number 14 of the BIVBlog, Benedict's IT video blog. My name is Benedict Stockerband and today I want to show you how to set up a PXE based network boot system as a sort of a rescue system for your network bootable machines. This is generally a good idea to do, but for my particular purpose it's the first step to make my training notebooks network installable. Because when I have a rescue system there, I can use it to install whatever disk images I like as a second step. Let's take a look. So the first thing we need is some sort of test machine, and I've set up Xen here on this system and have some convenient command line history things to start up a test virtual machine, so we can take a look at what happens there. Of course, this is not going to work, but it gives us an idea what the problems actually are. And the first thing we see is that our virtual machine tries to get addresses from a DHCP server. So that's what we have to set up in the first step. The DHCP server I use is IC-DHCPD, which is the biggest, full-featured, most commonly used DHCP server in the Unix world. It's a bit of a beast, but it gets pretty much everything done you might ever want, except that IPv6 support for it was way later than on some other implementations, but even that works, so we first get that. Okay, there it is. Now Debian has this habit or policy or whatever you want to call it of anything you install will get immediately started, which is a pain in this particular case because I take these machines to customers and the last thing I want is accidentally plugging myself into their network and starting to distribute addresses using DHCP. So I really don't want the DHCP server to start by default, but only through a script. The good news is that the DHCP server needs some configuration, and because it doesn't get any useful configuration from the package, it refuses to start, as we see here. And that gives me a chance to write my own little shell script that will start the DHCP server and use configuration from a non-standard location, so I can be sure that the DHCP server only runs when I really want it to. And this is how I do it. First, a little script to start the DHCP server. Okay, so this is the file we need. It's a little shell script. If you give it a command line argument start or none at all, it starts the DHCP server and it takes the configuration from the root home directory in dhcpd.conf, and it uses a PID file in the standard location, and it only listens on interface BR5, which is a bridge interface I use for this job. Another problem with Debian actually is that you can't configure these interfaces anywhere. You can't put them in the config file. That doesn't work. You have to specify them on the command line, and the Debian init scripts don't let you put them there. So another reason to do this manually, sort of thing. Okay, now when we try this, we get an error message, no config file, but at least the DHCP server is looking in the right location. So let's try touch dhcpd.conf, create an empty file, try to start again, and again we get an error message because we haven't provided DHCP with any information on what addresses it can distribute. So let's do that. First thing I'd normally do on a DHCP server is to add a configuration that it should use syslog. You'll find that in the example configuration as well. And then I have to tell it what networks or subnets to provide addresses for and from what range. And that looks like this. That's all there is to it. So syslog is configured, and we say in this subnet offer addresses from this range. And the address I use for this BR5 bridge interface is 10.255.255.1. So let's see if that works. At least the DHCP server is starting. And now let's try to start our virtual machine again. And we see it got an address 10.255.255.32, which is the first address from the range we configured. And that's good. That's all we need right now. At this point, we have DHCP provide addresses and network information, basically, like netmasks and so on. What's missing, because I don't need it, is a default router, a name server, a DNS domain, an NTP server, and all the other stuff you can provide with DHCP. You can add it in there if you want, if you need it, but I don't need it at this point, and I just want to keep this as simple as possible to get it up and running. So at this point, our PXE client has got its IP address, and that's the first step. The second step is a bit more complicated, because we need to provide the client with a file that it then executes to start whatever else it does afterwards. And for this, first we have to tell it the file name, what server to get it from. Then we have to set up a TFTP server to serve that file, and we have to find some file to actually put there. And this is probably the one thing that's a bit annoying. It's different for different Unixes. For Linux, we use a file called PXE linux.0. And that file comes from the syslinux package. And, well, we need to set up a TFTP server, get the file, and then tell through DHCP where to find it. So let's give it a go. First thing we need is the file. And it's in the syslinux package, which I had already installed. Okay, fair enough. And next thing we need is apt-get install TFTPD, which is a TFTP server. Now, the TFTPD is started through the inetd, or the OpenBSD inetd in this case. And the first thing you should do is check where the TFTPD wants to serve its files from. And if you take a look in the inetdconf, it says it's serve TFTP. So we create that directory. And put our file, which happens to be in user lib syslinux pxe linux.0, copy that to the directory. Good. Now let's try our virtual machine again. Doesn't work. Why not? Because we haven't told the virtual machine where to find the stuff. And we do that from the names from the DHCP server. So we need a file name, PXE linux.0, and we need to provide a server where to get it from, which happens to be our own address. Now, we stop our server, we start it again, and now we should see something new happen. There's the DHCP request. Okay, we got the file name to the client. It has done the download via TFTP, tries to do some sort of thing, and here comes next error, unable to locate configuration file. because this PXE Linux.0 needs a configuration file. So we have to provide that. And first we need a directory PXE linux.config. And in there you can put files that are named either according to IP address or MAC address, or you can go for a file that applies always, and it's called default. What do we do in there? We need a label, Wheezy, and that basically means that at the boot prompt you can actually request different configurations through these labels. And what we need here is a kernel, which goes into directory wheezy.vm, and it's called VM Linux. Bear with me for a moment. We have to provide that and get it somewhere, but we'll need to provide it afterwards. And we do an init rd wheezy/init rd.image, and we also do a prompt 1, always ask what to boot. It will do anyway because we don't have a default setting, but later on we might want to add a default setting, and the timeout 0 means doesn't time out. So that's our config file. Let's try again what the virtual machine does. So the next problem we should expect is that it can't find the kernel. And here's our prompt. We can add a little text file that is displayed so we can list the labels there, but that's a bit bells and whistles, so it doesn't really matter. Anyway, when we say Wheezy, there's our error message, could not find kernel image. So we need to provide that. Create a directory Wheezy and just copy our standard kernel and init.rd there. And in case you wonder why I omit the version numbers, it's simply easier this way when you do an upgrade. It might actually be possible to use symlinks here. I've never tried that with TFTP, but at this point I don't need it. And let's see what our client does now. DHCP is supposed to work, does, and we get the prompt. We say Wheezy. It's loading the kernel, it's loading the init.rd, and it's starting the kernel. Excellent. And now it takes a moment because it realizes it's running on in Xen domain. So what should happen next? We should get an error message that it can't find a proper root file system. And we have to set that up. We'll leave this booting and take care of the root file system. Now, for the root file system, we need two things. We need an NFS server to provide it with, and we need basically a full Debian installation, or, well, whatever other Unix we want to use. And the NFS server, we'll set that up in a moment. And then we actually use, in the Debian case, a tool called debootstrap to install a full installation. And after that, well, we have to tweak it a bit to make it actually work and allow us to log in, but that's all there is. Okay, let's go. So, apt-get install NFS kernel server. We get an NFS server. And nothing much about it there. Just takes a moment, and it won't properly start because the etc exports file, where we tell it which directories to serve, is basically empty. not starting kernel daemon, no exports. So it's called a warning, but it doesn't start. Now we make a directory serve NFS. So we put things there. Subdirectory PXE boot, because it's just convenient to keep all these things in one place, and one for Wheezy. And now we populate it. The bootstrap Wheezy serves NFS PXE boot Wheezy. This will take some time. It's possible to restrict the installation to some very basic stuff, which requires less space then, and it'll speed up things. But if I want a preferably largely full-blown rescue system, I rather go for the big installation. So that gives me a bit of a tea break, because it takes a few minutes. Okay, that's it. And now let's see what our virtual machine does at this point. It's booting. Well, pulling in the kernel, pulling in the RAM disk, and kernel is booting. And we run into another problem. It doesn't find the root file system. Now, this goes into the PXE config. And what we have to do is append some command line arguments to the kernel, which is root is def nfs, and nfs root is 10 55.1 / serve nfs pxe boot Wheezy. And I really hope I got this right at this point. So let's try. Doesn't work. Why? Because we still have to export things via NFS. And this goes here in the etc exports file. We say service nfs pxe boot is exported to everyone, read only, and but no root squash and no subtree check. The no subtree check is just something to suppress a warning. We exported read only, so people don't mess up the boot environment, and we can have multiple machines use it at the same time without them interfering with each other. And what's important is there's no root squash. By default, NFS maps the root ID to nobody, so root can't really use anything on this file system, and you don't want to do that for system file system export, so you have to use this no root squash option. And we will start the name server. And we don't even have to restart our virtual machine. It actually boots, and we get a boot prompt, or a login prompt on our virtual machine. So let's try to log in. Okay, that's the one thing we have to fix. We have to deal with the passwords, and the easiest way to do this is to change root into our NFS root file system, serve nfs pxe boot Wheezy, and then do something shadow config on, and give root a password. And if you don't want to have a password at all on this, which is what I want at this point, you can do something with ipw-s and just remove the encrypted password from the shadow file. And see if it works. Yes, it does. So there we are. We can boot our, well, virtual machine at this point, but it works with the physical machine as well, over the net without any hard disk or whatever working. So if things really go wrong on one of our machines, we can actually use a full-blown Unix to sort things out. What else can we do? Now, we can have multiple labels in the PXE Linux config file, so we could start either Debian or Fedora or OpenSUSE or CentOS or whatever. And we might even be able to boot something other than Linux. It's not quite that easy, and it probably involves so much work that I'm not going to try, because it's one of those things, to get this up and running properly might well take a day or two to work on. And I don't right now have any reason to do that. As long as I get a Linux as a rescue system, I'm fine. And at this point, the next thing I want to do is create a couple install images, binary images of all sorts of operating system. And yes, that will be BSDs and there will be Windows around there, because my customers sometimes want that. And then write that little front end to make it easy to say, okay, I want this. But that's for the next episode or so, because I think today we've got something done, and I think we deserve to call it a day. So if you have questions, if you want to discuss, if you think this is complete and utter nonsense because you have an install CD on your keychain or whatever, come over to the forum at www.stepladder-it.com/bivblog/14 in this case. And if you watched this on YouTube, liked it, do me a favor and give it a thumbs up. And in any case, hopefully see you soon. Bye.